Hello everyone, welcome to Jitendra Decodes. Today we will see the question explain Python's memory management and garbage collection. In one liner, I can answer it as Python uses reference counting plus a generational cyclic garbage collector and a private heap allocator, that is PyMalloc, to manage memory. Understanding this lets you avoid leaks in long running services and tune performance with tools like the garbage collector module and tracemalloc. Now let's break it down in very detail and see how you can respond to this question. So I always treat memory management as a first class performance and reliability concern, especially for services that run continuously or process large datasets. Now let's see how Python allocates and reclaims memory and why it matters for latency, scalability, and practical ways to diagnose and mitigate these problems. So the memory behavior affects the throughput, latency, and uptime of the application. Poor memory handling causes out of memory errors, garbage collector pauses, and subtle leaks that are costly in various domains and large scale web systems. In simple language, Python objects live on private heap, managed by the interpreter. Each object has a reference count, and CPython runs a cyclic generational garbage collector to clean the unreachable cycles that reference counting and cannot be freed. Small object allocation is optimized by PyMalloc to reduce the fragmentation and speed allocation. Now let's see a technical side of it, wherein reference counting is used for every object tracks how many references point to it. When it reaches to 0, memory is reclaimed immediately. This gives deterministic deallocation for most objects. Cyclic GCs. So Python's garbage collector runs periodically using generations, young to old, to reduce the overhead and find unreachable cycles. Then the memory allocator. PyMalloc handles small objects in pools to improve speed and reduces fragmentation. Large allocations go to the system allocator. Now let's see the variations in the garbage collection. So immediate deallocation. When objects are freed, when last reference is removed, they are immediately deallocated. Then there is a cyclic deallocation, where two objects referencing each other but not reachable for routes that require cyclic garbage collector to reclaim space. Then the allocation behavior. Many short-lived small objects are cheap due to PyMalloc pools. Many large objects can cause fragmentation and pressure on the operating system allocator. So let's see a quick example. Let's say in a quantitative finance application, it creates and discards millions of objects in quick time. Tuning garbage collector thresholds using object pooling, switching our memory to efficient data structures prevents pauses, and using of tracemalloc and garbage collector to pinpoint leaks in such systems will help in a great way. Now let's see common pitfalls that are generally faced in this situation and let's see how to avoid them. So the holding references unintentionally like globals and caches. So we need to avoid scoping or using weak references for the caches. Then finalizers underscore underscore del underscore underscore with dels with cycles can prevent garbage collector. Prefer context managers or weakref.finalize to avoid this. Blind tuning. Always profile first with tracemalloc. gc.get objects and object graph before changing the threshold. There are alternatives and complementary approaches like use PyPy for different GC strategy when just-in-time compilation and moving garbage collector and allocation patterns favors it. Design patterns. So generators, streamings, memory map files and explicit pooling reduces the peak memory. So in short, Python's memory model references counting, generational cyclic garbage collector and PyMalloc gives predictive behavior but requires profiling, discipline in long running systems. I always combine tooling, design patterns and targeted tuning to keep services stable and performant. Hope helps you in understanding and explaining the how memory management is done and garbage collection is done in Python. Thanks for watching. Please like, share, subscribe. Thank you.